There, now it's working. See, it's funny, if I argue with it, it starts to work. Okay, so here we go. Translating words into symbols. That entire blue section, you can read it yourself. Please look right below the blue box. Be careful with phrases involving 5 less than X, and I'm going to write this 5 less than X is literally X minus 5, because the 5 is how much X has lost. Okay, that's a huge caution. Okay, in the same way, 5 more than X. Now, I kind of disagree with them. If you write it that way, you should write it that way. But knowing that the properties of addition state that you can add in either direction, technically the result is still the same. But I say if you're going to follow the laws of language with this one, you should follow the laws of language in that one. That way you don't forget which one you can sort of swap. Okay? So I highly recommend following this. Now, I won't mark you wrong if you write that differently, the X plus 5, but this one absolutely has to be written that way. Okay, so your examples in the book are for your leisure. You can look at them as you wish. I'm going to give you my examples. That way you can look back and have multiple things to compare your questions to. The book, of course, you all know how to read, and my examples for you. So this entire assignment continues to use you translating words into symbols, not necessarily solving anything, okay? For example, if I say 3 times a number, how would you say that using symbols and letters, or symbols and numbers? You would say 3n, right? Okay, that's all we're doing. You're not going to tell me, well, 3n is 12. You don't know that because you don't have any way to solve that. So this entire exercise, for the most part, is going to be simply your translation, not solving anything. All right, so example 1 starts like this. 12 more than a number. This is my sample. You won't find it in your book. How would you translate that? Well, just like this one, you're going to write N, X, Q, whatever. Okay? 12 more than what? 12 more than a number. Okay? 12 more than a number. And then they get a little trickier. 1/4 of a number and 6. Okay, 1/4 of a number. 1/4 of a number and 1/4 of a number and 6. Yeah, 1/4 of a number is going to be 1/4 n. That's going to be 1/4 n. And is a word oftentimes used for add. They don't have that in there, which is why I wanted you to have that. Okay? 1/4 of a number and 6 is add. Okay? Now, this is a tricky one, and you're going to see this, and I guarantee you, you're going to feel, oh, what do I do? Here comes the tricky one. One-third the difference of a number and 2. Holy cow. Right. Philip's right. Okay, 1/3 we get. But the difference of a number and 2 is something that you need to figure out before you can deal with the 1/3. So 1/3 of, and I'm inserting the of in my mind because when it says 1/3 the, you can automatically insert the word of in your mind. For simplicity's sake of speech, you don't always use it. So 1/3 of the difference of a number and 2. Okay? Notice the difference here. 1/4 of a number and 6 or plus 6. Whereas 1/3 of, they tell you this has to be solved, therefore those parentheses have to be in there. Another way they might do this little tricky thing, they might say 1/3 the quantity of a number and 2 or something. That's their way of trying to isolate and tell you that you need to figure this detail out first. Okay? Tell you what, I'll give you one more of those tricky ones. Maybe you get it, maybe you don't, but I'm going to give you one more. 9 times the quantity of a number and 1. There's another tricky word. The quantity of, that's telling you you need to know what a number and 1 is. A number and 1. So 9 times the quantity, a number and 1. Okay? That's the end of the real tricky business that you're going to see, honestly. It's not terrible. Top of page 15, I'm going to flip. You don't have to. Top of page 15 is where example 2 begins. Example 2 begins, and they give you some helpful formulas. Honestly, you've all used most of these. Area is length times width, perimeter, length, width. Distance is rate times time. And the cost of something is the number times the cost of each one. So if you buy 10 gallons of gas for $2 each, you're paying 20 bucks, right? Okay. You're going to see all those used here throughout. But before we get there, example 2 is going to say to you, well, how can you indicate information about lengths and widths and things like this? So I'm going to give you another problem similar to that, okay? The length of the paper is a number, okay? Its width is 4 inches smaller. Give me a way to describe that. So the length of the paper, I'm just going to call L. We're going to call it L. You can call it whatever you want. The width of the paper, if it's 4 smaller, Philip, how would I say that? 4 smaller than L.
L minus 4.
He's right. L minus 4. Okay? Using that information is going to be very, very helpful to you. I could have said its width is 4 inches bigger. And it would be L plus 4. Okay? Or I might say this. Length, I'm using the same thing, is a number. Width is twice the length. Okay? You might see that. Same kind of scenario. Length of paper is length. How would I indicate width of the paper, Ethan? Twice the width, or twice the length, you mean? Sorry, I can't hear. Double. Good. You double it. If it's twice the length, you simply double the length. Now, all of those perimeter, or all of those formulas there for you. Find the area and perimeter of a rectangle with a length of 10 and a width of W. Hold on. How can you do that if you don't have any information about the W? Well, don't worry. You're not really giving me a real answer. You're using the variables to explain the situation, okay? You are not going to give me inches, feet, or yards with any clarity yet, okay? So we're going to do something similar to their sample. I have my own in my book for you. So I have another one. Okay, we're going to use that one. I'm going to use mine. Okay, example 3. Using a formula, we're going to do area and perimeter of the following. Length equals 6, width equals width. Okay? Now, what on earth does that mean? Well, that means I have no information about the width, but I can use the area formulas, which is whatever the length is multiplied by whatever the width is. I can use the area formula. I can also use the perimeter formula, which is doubling the length added to doubling the width will give me a perimeter, right? The length is 6 units. The width is W units. Therefore, that's your answer. You don't know anything else, okay? Don't feel like you can give me more than you know, okay? Perimeter. Perimeter, I know that the length is 6. So 2 times 6 is equivalent to 12, right? And since I don't have a variable or I don't have a number for width, I'm just going to keep my width variable where it lives. So your answer looks like that. You don't know anything else. You can't tell me anything else, okay? Don't feel bad about that. You're telling me all you can. All right. Okay. If you have your book in front of you, example 4, this is using, mine is going to use the same formula. Cost is equal to count of item times price. You guys do this all the time. If you go out to eat, you kind of have to figure out what you're going to get based on probably how much money you have or how many of you there are. 15 volleyball players buy 6 hot dogs at a cost of H dollars each. In other words, I have no idea. And they purchased 9 burgers at $5 each. Okay? I'm reasonably certain that none of you would have a problem telling me you spent $45 on burgers, right? Right? You know this because this is easily solved. 9 times 5. But if you don't think about it, you might get a little nervous about this portion. I'm going to break it down. So number of burgers multiplied by their dollar amount added to the number of hot dogs multiplied by their dollar amount is going to give you the total. Okay, because you bought burgers and hot dogs. Okay, 9 burgers times $5 a pop added to 6 hot dogs at H dollars a pop is going to give me my total. 45 plus 6H, right? 45 plus 6H is going to be how much you can tell me. 45 plus 6 times whatever the hot dog cost was. Why? Because you bought 6 of them. Burgers are easy. You knew what they costed. Okay? So we've talked about area. We've talked about perimeter. We've talked about cost based on what you buy and how many you buy, right? Last one is distance equals rate times time. Anybody in here run or bike or do anything speed related? Okay, speed related racing, whether it's on a bike, swimming, any other type of things you might do, is always related to time. Your goal is to go as fast as possible. And so you want to cover a certain distance, a quick rate, and in a short time, right? Driving, everybody knows that if you travel 65 miles an hour and you drive for 1 hour, you're only going to cover 65 miles, right? Unless you speed, and that's a whole different story, right? Distance equals rate time is example 5. Last thing on this page, and then you guys can stop listening to me yak. Okay? Example 5. Okay? Example 5, and this is my example. Okay, so it has to do with what you may or may not know. Okay, so I'm going to break this down a little bit for you. Their example is going to be similar to mine, but I want to give you another one. Time is usually in hours, and in our country, rate is miles per hour, and in our country, distance is in miles. Okay, if you're an overseas person, you're going to use kilometers. Okay, but you'll still use hours. Kilometers. So let's just say I say to you, you traveled a certain amount of time, and then you got back in your car for a half an hour longer. Okay, you traveled for a certain amount of time, and then you got in your car for a half an hour. Oh, geez, that's the same example they have. All right, you traveled for a certain amount of time and traveled for another hour. Okay, so your time is a certain amount of time, which I have no idea what it is, but I do know I traveled an hour more than whatever it was that I started with. So it might be something like this. The word problem might read in later lessons, you traveled for a little while, and then your partner took over for another hour. So this is just the vehicle moving. It might be written like this. This is how long you've been traveling. Your rate of speed was 65 miles per hour. There's my rate. How far did you travel? Your distance is going to be equivalent to the product of these two things. So your distance is 65 multiplied by h plus 1. You cannot tell me anything more than that. Okay? There's nothing more you can do. I could tell you another story. I might say to you, in comparison to me, my brother traveled an hour less. In comparison to me, or 2 hours less. So if I were to subtract 2 from this, I'd have a slightly different scenario. Okay? Today's assignment is odds, lucky for you, because you're going to feel uncomfortable with these. Check your answers. Okay, but you need to learn.